I'm Shyamala, Assistant Professor of Mathematics in Nalla Narasimha Reddy Institute of Technology. In this video, I'm going to discuss about problem on finding eigenvalues and eigenvector. So the problem is finding the eigenvalues and corresponding eigenvectors of the matrix A. To find eigenvalues, we consider the characteristic equation determinant of A minus lambda I equal to 0. So first see what is A minus lambda I. A minus lambda I equal to, this is the matrix A minus lambda into I is the identity matrix of order 3. A is 3 by 3 matrix, so I also we take the matrix of order 3 by 3. And lambda into this identity matrix gives us lambda 0 0 0 lambda 0 0 0 lambda. If we subtract these two matrices, we get 2 minus lambda, 2 minus 0, 0 minus 0, 2 minus 0 2, 5 minus lambda, 0 minus 0 0, 0 minus 0 0 0 minus 0 0, 3 minus lambda. So A minus lambda I matrix is this one. So if we observe A and A minus lambda I, the difference is simply only the changes are there in the diagonal element. 2 minus lambda, 5 minus lambda, 3 minus lambda. All the other elements remain the same. Now we will take a determinant of A minus lambda I equal to 0. So to this matrix we are finding the determinant. So how do we find the determinant? First we take first row first element 2 minus lambda into the cross multiplication of these two elements 5 minus lambda into 3 minus lambda minus 0 into 0 0 minus 2 into, this is a formula for the determinant. For the second element we write minus 2 into 3 minus lambda minus 0, that is what we have written here, plus third element is 0, 0 into something 0, that is why I am not writing anything. If we take also 2 into 0, 0 minus 0 into 5 minus lambda 0, so we get 0 for the third element equal to 0. This is the determinant. Now we simplify this equation. 2 minus lambda we keep as it is, or what we are doing is in these two terms 3 minus lambda common here and here also 3 minus lambda, so I am taking out 3 minus lambda, then the remaining terms will be 5 minus lambda into 2 minus lambda in the first term, and here the remaining term is after taking out 3 minus lambda 2 into 2 4 equal to 0. Now 3 minus lambda will keep as it is. Now we multiply these two terms. Lambda minus lambda into minus lambda, lambda square, minus 5 lambda, minus 2 lambda, minus 7 lambda. Then the constant is 5 2 10. Then the remaining one minus 4 is here. So that is what we have written. So in the next step we will get lambda square minus 7 lambda plus 6 into 3 minus lambda as it is equal to 0. So that is what we have got. 3 minus lambda into lambda square minus 7 lambda plus 6 equal to 0. Now so lambda 3 minus lambda equal to 0 and lambda square minus 7 lambda plus 6 equal to 0. Now we will find the roots of this quadratic equation. So to find the roots we will write minus 7 lambda as minus 6 lambda minus lambda plus 6 equal to 0 and lambda equal to 3 for this first term. So in this quadratic terms we are taking lambda common, then lambda minus 6 we get here. From these two terms if we take out minus common, then we get lambda minus 6 equal to 0. Now lambda minus 6 is common in both the terms. So lambda minus 6 if we take out, here lambda will remain and here minus 1 will remain. Lambda equal to 3. So the eigenvalues of the given matrix A are 3, 6 and 1. So now these are the eigenvalues. Now we have to find the eigenvectors for these eigenvalues. Eigenvector corresponding to lambda equal to 1. So to find the eigenvector, we take the definition A minus lambda I into x equal to 0. What is A minus lambda I? We have written it first. A minus lambda I, this matrix, into x is the vector, which is a column vector which contains 3 unknowns, because A is a 3 by 3 matrix. X is a column vector which contains 3 unknowns. That unknowns we can write in x, y, z. Otherwise we can write in x1, x2, x3. So now what we have to do is we take the lambda equal to 1 and substitute in this matrix. Then we get 1, 2, 0, 2, 4, 0, 0, 0, 2 into xyz equal to 0. Now our aim is to find the values of xyz. So as you have learned in the first unit, to find the unknowns we have to use the row transformations, and we will make this 2 as 0. So to make the 2 as 0, we perform the row operations. So what are the row operations are? On R2, we are going to perform the operation that R2 minus 2 R1. So R1 we will keep as it is. On R2 we are performing. So what is the row operation? R2 minus 2 R1. 2 minus 2 1 2. 2 minus 2 0. 4 minus 2 2 4 0. 0 minus 0 0. Last row will keep as it is. Writing this matrix into equations, we get, because this is the echelon form, I'm not going to write everything formally, because we are going to concentrate mainly on the eigenvectors, not on the echelon forms and all. So if we write this into equations, we get 1 into x x plus 2 into y 2 y 0 into z 0 equal to 0. And from this last row we will write 2 into z equal to 0. Remaining terms are zeros. Now 2z equal to 0 gives us z equal to 0. So z value 0 we got. Now we have to write x and y values. So we have only one equation, but we have to find the two unknowns. That is why what we have to do is we have to take y as some k. Then we will get x as minus 2k. And then we write the eigenvector. So this is a first eigenvector. So let us denote it with x1. x1 is actually xyz. X value minus 2k, y value k, z value 0. And take out k, then we get minus 2, 1, 0. Usually when we want to use the eigenvectors, we will ignore this k, or we will fill that k value as 1. Now we find the eigenvector corresponding to lambda equal to 3. Again we take A minus lambda I into x equal to 0. That matrix we will write A minus lambda I. In place of lambda we substitute 3 here. Now what do we get? 2 minus 3 minus 1. Remaining elements are same. 2, 5 minus 3, 2. Remaining elements are same. Third row is 0. 3 minus 3, 0 we get. Now we perform row operation and make this 2 as 0 by using R1. So the operation is R2. On R2, R2 plus 2 R1 if we perform, then we get first row remains as it is. On the second row, 2 minus 2, 0, 4, 2 plus 2 2 4, 6, and then 0. Then last row is 0. So writing this matrix into equations, then we get minus x plus 2y equal to 0, 4y equal to 0. 4y equal to 0 gives us y equal to 0. If we substitute y equal to 0, then we get x also as 0. So, and we don't have any information about z. So let us not take z as 0. Since we don't have any information, we take z as some k. Then the second eigenvector is x, y, z, which is 0, 0, k. If we take out k, we get 0, 0, 1. So whenever we want to use x2, then we will take k as 1. Now we will find the eigenvector corresponding to lambda equal to 6. Again we take a minus lambda I into x equal to 0. And then a minus lambda I we write like this. In lambda equal to, in place of lambda we substitute lambda equal to 6. Then 2 minus 6 becomes minus 4. Then 5 minus 6 becomes minus 1. 3 minus 6 becomes minus 3. Now we perform row operations on R2 and make that first element as 0 by taking R2, 2R2 plus R1. So second row becomes 0 and then third row we are keeping as it is. So this is the matrix which we get after the row operation, and then we write them into equations. First equation is minus 4x plus 2y equal to 0. Minus 4x plus 2y equal to 0 is the first equation. So last equation is minus 3 into z equal to 0, which gives us z value 0. Again, we have one equation in two unknowns. Let us suppose x value as k. Here we can take any value as k. We can take x value as k, or we can take y value as k. There is no problem. So if we take x value as k, then we get y value as 2k. So the third eigenvector is x3 equal to xyz, x value k, y value 2k, z value 0. If you take out k, then we get 1, 2, 0. So the eigenvectors are, as I said, k equal to 1 we can take, then the eigenvectors are minus 2, 1, 0 is the first eigenvector, second one 0, 0, 1, third eigenvector 1, 2, 0. So this is a way of finding the eigenvalues and eigenvectors of a given matrix, and in this case we got the eigenvalues as distinct eigenvalues. That means there are no repetitions in the eigenvalues. Our eigenvalues are 1, 3, 6. All are different eigenvalues. So whenever we have a different eigenvalues, then this is a process of finding the eigenvalues and also eigenvectors.